Hey everybody, welcome back. Today we will be taking a look at catalyst and activation energy, which will be the last lesson for this unit. So what is activation energy? Well, according to collision theory, for a reaction to occur, there are two things that need to happen. First of all, molecules need to be in certain orientation. So need to be in the correct orientation. Okay, if you remember back to Chem 20 bonding, uh, they form different shapes. Compounds form different shapes like tetrahedral, trigonal planar. Those molecules are going to line up and react with each other. Second thing, which we will be focusing on in this unit, is they need a certain amount of energy. So need a certain amount of energy. All right, next, our learning goal. I understand that a catalyst lowers the activation energy of a reaction, but does not change the enthalpy, does not change the enthalpy of a reaction. Catalysts do the following things. They can speed up a reaction. So it happens faster, saves money, saves resources, doesn't, oh, that is very badly spelled, doesn't change delta H of a reaction. And then lastly, it lowers the activation energy. Okay, so let's take a look at the diagram. We have seen potential energy diagrams already in the unit. They looked like this. I'm just going to do a quick sketch. They look something like that, or looked something like this. Now I'm going to add to these diagrams. So same thing. We're going to first start off with our axes. On this side, we have our potential energy in kilojoules. And on this side, we have our reaction coordinate, or our time or progression of reaction. Doesn't matter, whatever you feel like writing. Okay, so what we're going to do next, so the first line, it may be low or high, this is going to be our reactants. Okay, and then we have this little hump of energy. This is called our activation energy. That's that energy that you need for the reaction to happen. If that certain amount of energy is not reached, it's going to not have the reaction happen. Okay, and then we have our products down here. All right, in different colors, I'm going to do some labels. So from the reactants to the top of this little bump, this is going to be our activation energy. Activation energy. Okay, and I'm just going to label this A, because on the side, A, to calculate this, you would take the energy of, so you would take the top, uh, the activation energy, and you would subtract the um, energy of the reactants. Okay, the next one I'll do in green is from the products to the reactants. This is our delta H, okay, and I'm going to just label that as B. To find B, what you will need to do, delta H is equal to the potential energy of the products, so EP products, erase, potential energy of the products minus the potential energy of the reactants. Okay, and then C, let's do that in purple. From here to here, label that as C, that's your reverse potential energy. Oh, not potential energy, reverse activation energy. So let's say if we wanted to do this reaction the other way, and they ask you what is the reverse activation energy, or what is the activation energy if the reaction was reversed, well, that would be from the products to the top of the activation energy. So top activation energy minus energy, or your PE, potential energy of your products. Potential energy of your products. And I'm just going to change this one too. My computer does not like me today. Potential energy of your reactants. Okay, so I'm going to leave that at there, and the activity I've planned for you in your practice is I'm going to give you guys some values here on the side, and your job is going to be to calculate A, B, and C. Okay, now the last thing we're going to talk about, and I'm going to do that in pink, is your catalyst. So catalysts are always drawn with dotted lines. Okay, so let's take that off to the side. Catalyst is drawn with a dotted line. So if you see a dotted line, that's the activation energy if a catalyst was used. And you would know it's a catalyst because it's always drawn with a dotted line. All right, so we will see you guys in class.